My name is Deodatus Stanley-Kiriba. I work with the Tanzania Agriculture Research Institute in Tanzania. I'm also a member of ASAT, which is the Astronomy and Space Science Association of Tanzania. I'll be presenting a brief presentation on hands-on activities for the universe observing using locally made and low-priced instrument. So I'll be using the case study of the Young Astronomers briefcase. So this is the highlight from the globe where Tanzania is located. So basically Tanzania is located in East Africa, in the African continent. So this picture shows the network for astronomy school education training that was conducted in Dar es Salaam. So basically the training aimed at training the teachers from secondary schools on different aspects in relation to astronomy, and where basically the Young Astronomers briefcase training was given. So in a brief, the Young Astronomers briefcase contained different tools, which ranges from the ruler, simplified quadrant spectroscope, simple horizontal galvanometer, planisphere, map for the moon, equatorial sun dune, the red light flash, the compass, the wristwatch, and the paper, pens, and the camera. So for the case of this presentation, I'll only be presenting the three equipment or tools that are contained in the astronomer briefcase, which is the ruler, the simplified quadrant, and the telescope. So when we say the low technology, these are the equipment that are locally available and can be made by students within their locality. For example, the student can have a ruler or can use the ruler to measure the angular distance between the stars or 2 points in the class. So basically, a ruler can be used to provide the angular distance between the stars or any two objects that are differing in height. So you need to have a string which is 57 centimeter, and it is tied up at the middle of the ruler. So you can use the ruler that is 30 centimeter. You just tie a string which is 57 centimeter. So then you can use that ruler to just observe by your eye, like the tool, to measure the distance from where you are to a distance. So the angle that is made between the string and that object is the angular distance. So as we all know that 1 degree centigrade equals to 1 centimeter. So you can calculate the distance in terms of angle. So we can also use the simplified quadrant. So the quadrant is basically, it is a gun-shaped equipment where you can have the board, which is made like a gun. And then you can put the scale and you use it to observe the distance or the attitude between the stars. So the body should be 12 by 20 centimeter, and it has to be hooked by a rope. Then when you observe, so the angle that is made by the rope is actually the angular distance between the observed stars or the observed object. Then the other tool that a student can make is the spectroscopy, which can be used to indicate the solar spectrum. So this is basically, you can have the matchbox and the piece of the CD. So when the piece of the CD is illuminated on the sun, it gives you different, it reflects different colors. So these colors can give you the spectrum, the solar spectrum. So you can just make a hole on your matchbox, and then you have a piece of CD, you insert in your matchbox, then you can, so in the one end, you don't cover the matchbox, so you can use observing through the hole. Then you can see the spectrum of the sun. So this training was given to the teachers where they can basically train their student in class, and the student can have a box of these instruments. So with this regard, that marks the end of my presentation. So thanks to Dr. Jiwaju, who has been providing mentorship to us on astronomical issues. We are also thanks to ASAT and to the primary and secondary teachers in Tanzania. Thank you.